New breast cancer SNP testing by Gene Nexus. As the second most diagnosed cancer in women, about 12% of women in the United States will develop breast cancer in their lifetime. Breast cancer in males is less common, holding less than 1% of all breast cancer diagnoses. Breast cancer is a disease in which cells in the breast have abnormal growth, forming a tumor. Most commonly, the cells lining the milk ducts is where breast cancer starts. As breast cancer progresses, symptoms can arise, such as a lump in the breast, tenderness, or skin irritation. In many cases of breast cancer passing through families, the pattern of inheritance and genetic basis for the disease are unclear. For hereditary breast cancer, the gene involved affects the risk of developing breast cancer. For mutations on the BRCA1 and BRCA2 genes, the pattern of inheritance is autosomal dominant. This means that only one copy of the mutant gene in each cell is enough to increase a person's risk for breast cancer. BRCA1 is found on chromosome 13, and BRCA2 is found on chromosome 17. Both of these genes code for a protein that acts as a tumor suppressor. BRCA1 and BRCA2 mutations are most common in breast and ovarian cancers. Approximately 10,000 women over 20 years concluded that women with BRCA1 mutations have on average a 72% risk of developing breast cancer by the age of 80. 23andMe tests 44 out of over 4,000 variants in the BRCA1 and BRCA2 genes that are known to increase the risk of cancer. One SNP on the BRCA2 gene that is considered to have risk alleles for breast cancer and is tested by 23andMe is RS11571746. Also known as S2835P. This SNP is one of 25 SNPs reported to represent independently minor but cumulatively significant increased risk for breast cancer. The variation of this gene determines its risk probability. While 23andMe does test for 44 variants of breast cancer in the BRCA1 and BRCA2 genes, it is estimated that there are hundreds of additional SNPs that could impact this disease. Our genetic test here at Gene Nexus expands on the 44 variants already tested by competitors by testing for over 50 SNPs of the BRCA1 and BRCA2 genes. For example, the SNP RS2981582 is one of the most important variants which has been linked to a higher level of FGFR2 transcription in both breast cancer cell lines and tumors. The SNP RS2981582 is located in a non-coding region of the FGFR2 gene in the upper portion of the intestinal crypt, so it does not alter the protein structure of expression directly, yet may still influence the gene expression and other regulatory processes. The typical role of the FGFR2 protein is to encode a receptor protein that binds fibroblast growth factors together, playing a vital job in cell growth. With a mutation of the FGFR2 gene, 1 out of 6 women are affected and carry a 60% increased risk of breast cancer. Many of the variations in BRCA1 and BRCA2 are individually minor but cumulatively significant. This means that many variants must be tested to see the full picture of one's risk. By testing over 50 variants that are known to increase the risk of breast cancer, our test is the top genetic test in the country. Crucial for people to fully understand the limitations of genetic testing to make educated decisions about their health. Although genetic testing may be beneficial, there are limitations for the risk of breast cancer. First, specific alleles that can impact breast cancer risk may only cause a slight increase in susceptibility. Further, the base risk for breast cancer can change among individuals with a combination of genetic, environmental, and lifestyle factors. For example, the average lifetime risk for developing breast cancer for any given woman in the United States is roughly 12%. However, this risk can be much higher or lower, depending on family history, age, and reproductive history. Next, even with advancements in genetic research, there are many unknown external variations that can influence breast cancer risk. While our experiment includes additional SNPs beyond the 23andMe test, it is impossible to cover every potential genetic factor. As research advances, new genetic markers will be discovered that will further define our understanding of breast cancer risk. A genetic test to then find out you have a concerning risk of breast cancer is emotionally trialing. Then to add salt to the wound, the preventative measures like mastectomy in this case run a high cost of $11,773 on average. However, getting tested early allows you to determine your future. You can take the power back and decide how you want to live life to the fullest. At GeneNexus, we promise to be the best genetic test available when testing for variations that can lead to breast cancer.